Hello guys. Let's see. Let me know if I'm live because I've never streamed before. Let's see. Cool. I'm good guys. How is everyone? How is my code? My lovely code. Can you hear me? Thank you. Nice. Yeah, we'll wait a few minutes to let more people come in and yeah. Let's see. Cool. We'll wait 5 minutes in and then I will start. I need to wear a hoodie because I have a problem with the electricity. So you can only have the light on if the ceiling fan is also on, which is a bit annoying. So it's yeah. Who is going to be the 500 stars? Let's test the resolution. Let me know if you guys can see anything. Can you see this one? Let me know if you guys can see the code. If not, I will try to figure. Yeah, cool. There is a bit of a delay between when I speak and I see your comments. So just know that when you... Yeah. I can see this, Jack. I can see the comments, yeah. Awesome. I feel like I'm a Twitch streamer now. Anyway. All right. I say let's start. And guys, thank you for jumping in. And this is also being recorded. So guys, you can watch it later. And obviously, I'm here available for questions and even like jumping on calls and trying to debug things together. What I'm going to do today, essentially, I would love to go over the code, the different components. I'm not sure if we will be able to dive line by line and things like that. More of a general like code sections and things like that, and how things are connected. Oh, cool. And how things are being connected, and maybe let's see how long it will take us, but maybe let's try to configure Supabase and even run the app locally and try to do everything from scratch. So let's start. So basically, for the app, we have three main components. We have the backend, which is where we have the database and where we process the data. And we are using Supabase for it. We have the device itself, the physical device, and we have the app where you interact with it. Where you interact with it. These are the main three components, and I think it is best to just start with the device. It's straightforward. I think it's one file. It has dependencies as well, but it is mainly like one file that I built and changed and stuff like that, and then we will go from there. So we have this the on device. Yeah, I need to be careful with the secrets. Let me know if you see a secret, and I will make sure to revoke it. Okay, so when it comes to the device, the physical necklace that you are wearing, you have this folder, devices. Right now, I envision that we will have different versions. Like we will have a Core AI device, we will have a Raspberry Pi Pico or Zero. Like we still need to figure this out. But right now we only have the Core AI one, and it contains a main.cc and a CMake file and a check output. And then we have the Core Micro library, which is basically the dependency library of Core Micro AI devices. Yeah, cool. So main.cc, this is where we start. We start from here, obviously. This is the just starting the app, calling main. Main is the main function. Let's see where it starts. Cool. So this is main, making sure we are printing to the console. By the way, something I spent maybe an hour on is that if you don't write /r/n, which is new line essentially, then you won't see it in the serial output. Like until you write those two, it's not being sent to the debugging console. Then we are letting up the LED light, this orange light over here, and we start setting up our Wi-Fi. So for this part to work, which is where we set up the Wi-Fi, you have to have the Wi-Fi /Bluetooth add-on, and this is why you need to have this if statement here as well. For some reason, if I don't have it, trying to compile the code just fails. So you have to have this weird if statement here. We turn on the Wi-Fi. If not successful, we fail. Then we connect to the Wi-Fi, and then we get an IP. Basically, we are sending a DHCP request. DHCP request, yeah. And we should get our IP. If it fails, if it didn't get the DHCP response, it fails. If not, continue. Yeah, and then we initialize this A71 chip. don't know much about it. I used the examples from Coral AI repository, but I read a little bit about it, and it's essentially a physical chip that we have on the Coral AI device that help with some security stuff. Like it helps with cryptography, like certificates and signatures and things like that. I'm happy to read more about it. I think everything should work even without this. It should be okay to delete this. But if you go to the Coral AI dependency tree, so in our devices, Coral AI, Coral Micro, which is again the dependencies, and you go to examples and the curl example, you will see they are using the same kind of like stuff. Cool. So there is that. And then we are starting the recording, right? So this part took me forever and a lot of GPT-4 back and forth. Yeah, so when we are going to write this for the Pi Zero, we will need to basically rewrite the whole thing, just because the entire dependency, like the Coral Micro, won't be relevant. So just the main.cc will need to be rewritten to use the relevant hardware on the Raspberry Pi. But I think it should be all right. It will be fairly straightforward as well. And I mean, I'm not sure about Python. We probably are going to use C++ for the Raspberry Pi as well. Cool. So yeah, back to the audio. So now we have this, basically we have a microphone hardware on the Coral AI, and we need to be able to integrate it. So first of all, we create an instance of the audio driver, and then make sure it's actually like on, and we can collect audio samples from it. And this is the audio driver config. This is basically tells us how we collect the audio. So in this case, we're using 1600 hertz, which is the sample size, like of the wave of the audio. Here we have 2 channels. I think it means stereo, and 50. I'm not sure what is the 50. Maybe it's the batch sample. I can dive into it in a second. Cool. So all of this is just configuring the audio driver, and it is crucial part because this will need to be aligned with what we are using in the codebase function, because from the device we are not sending an audio file. We are sending from the device to the backend. We are sending a raw audio, so just like bytes essentially. And then in the backend, we are converting the bytes into an audio file, which can be either MP3 or in our case, a WAV file. And all of those parameters will need to align with what we have in the codebase function. Okay. And then after we have the driver, we create a reader. I think it's essentially a way to just start reading from the hardware, and we start a while loop. We have audio data, which is just a vector, just like to hold the data, and we read from the reader, from the buffer, and insert it to the vector. I think in this case, every time we read something, it's going to be this size of like 50 bytes. Yeah, insert it to the audio vector. This one is also crucial. This is the way we save it. So we save each I don't know how to name it. but we save the bytes in int32 form. And it's also important because we will need to address that in the Supabase side. Anyway, we are checking that our audio data, which is the vector that we are storing, reached a certain size, which means basically 16 seconds, and you can adjust it to whatever you want. And then we're just sending it to the backend, and we will dive into the send audio data in a bit. And after we're sending the data, we clear the buffer, the audio that we are storing, and that is it. Now let's dive into the send audio data. Cool. And I will stop after that. I will stop for questions on the main.cc part. So in this case, we are creating a curl request, which is essentially an HTTPS request to our Supabase server. Yeah, this is the address of the function that we are going to invoke, which is like, we will see what it is in a bit. And the full URL is the Supabase URL. So we're creating the full URL, like the Supabase URL plus the invoke function. Yes. Yeah, 1 second. RC is asking a question. I was just going to finish the curl explanation, and then we will dive to the questions. So all of this is just, it's like a curl, an easy way to set up a curl request, a HTTP request. So this is the URL, the certificate. I think it is self-signed certificate, which means like, doesn't mean much, but it is part of the curl micro dependency tree. Setting out what's the size, headers. I think this is empty. The headers are just like appending like the content type a WAV, this is probably incorrect, but for some reason it still works. Yeah, I'm not sure what all of those other settings are. This is just the settings to enable like a bit more debugging output. And then just trying to mark like 3 times, trying to send it. So performing the curl request. If it fails, if it's okay, break, else try again. Maximum, like wait 5 seconds and try again. This part can be extremely improved, but for example, during those 5 seconds, I think we are not recording any other data, which is a bit of an issue. And just I'm trying to understand those two. Basically, just the data itself, the post fields. You send the raw data, the bytes. This is the important part essentially. The data, we send this in the post fields. And that is it. Like it's just going to send and send and send and send endlessly. And that's the main.cc. So if you have questions on this part, just let me know. So for compilation for the Rasp code, I actually didn't get to that to do that just yet. I have an issue with my Raspberry Pi. I don't have a analog to digital hardware, the other hardware component. So I just bought the digital microphone, and I hope it will be easier to set up, and then I'll let you know as we progress. But also, I know like few people on the Discord started doing that as well. So just feel free to share notes. Any questions on the main.cc? This is the whole code that runs on the. Yeah, so we are sending the raw bytes directly to the Supabase function. So it's not yet a file. So you will see in the Supabase part in a second, you will see what I mean by that. But it's just like bytes. It's just bytes, and that might contain audio data if they are being looked at in the right way. Cool. Awesome. So from there, just a quick check output. It's the simplest Python script where you connect to your serial device, which basically means when you connect your device to your laptop via the USB-C, USB-C is able to act as a serial wire as well, and it just trying to get all the data from it, encode it, and print it. Very simple. You might need to plug out and plug in when you change between different versions because it fails. But other than that, that is it. Cool. CMake is just the way to basically tells like how to compile the code. It is including like directories and subdirectories, which is the dependencies for micro. It sets the executable to be main.cc. It adds specific libraries. It adds specific libraries as dependencies. This is the so-called operation system of the microcontroller. This is what gives you access to like files and things like that. This is the kernel that we are using to send the request. This is like the library. This is the library to interface with the security crypto chip that I mentioned, and this is a library to integrate with the Wi-Fi. This is to like environment variables. Yeah, let's see the cool. And that is it. Let's go quickly to here just to go over the setup. So this is the command that actually compile the code. So make _c out like where it's going to be put at, and then after it's been compiled, we are flashing it from the out folder to the device. This is Wi-Fi and password. Basically, those two arguments write a file to the operation system, which then being fetched by the Wi-Fi Connect. So Wi-Fi Connect fetches those arguments from a file. Cool. Awesome. Now let's finish with the device. If you have more questions, feel free to ask, and I will answer them. Now we have the Supabase. So the Supabase has two functions, one called chat and one called process audio. And common is basically just like a shared utility functions between those two functions. And it has also a schema. This is all can be automated. The setup, like I know right now I told you guys to just copy and paste it into Supabase, but it was because I was a bit lazy to make it like a one command to run this as a migration, but we will do it in the next few days, I'm sure. Cool. So because we came from the main.cc, from the device, I think the best way is to start with process audio, which basically is the other end. This is the function that gets the data from the device. So let's check this out. Okay, so let's make it a bit less scary. Okay, so this file, it's what's called a dino function, which is a way to serve JavaScript as an HTTP server behind one endpoint. So this endpoint will be the one we have set here. Okay. All right. So let's start. So basically, we get this is being called, and we get the request object. We make sure it is a post request and not other requests, and if not, throw an error. We create a server-based client. So this server-based client, because we run in a server-based environment, it will automatically fetch the server-based URL and the unknown key from your environment. So you actually don't need to set this up yourself, unlike the OpenAI key, which you do need to set up yourself, but this automatically been created. We create an OpenAI client as well, and I might show at the end how to set this up with Ollama, but it is really like 2 minutes work. It really fast. The only issue is the whisper. So Ollama doesn't have a whisper supported just yet. Hopefully they will have one soon. This OpenAI API key we will need to set ourselves in a bit. And here we basically get the request raw post data. So request.array buffer will give us the data. Like this what this means. Cool. We might have an issue here that it is integer 8. I'm not sure, but it is working, so we'll see. And then we remember when I told you guys that we send the raw audio data. So it means I meant it is not a file. It's not an audio file. So if you save it to like something.wav and try to double click it, no, like you won't be able to hear anything. And this is because you need to create a file header. Basically tells the operation system, like the OS, tells it how to read the data, and this is also needed, as far as I know, in order to send it to OpenAI. So the header, we basically send the length, the hertz, like the wavelength, the integer size, the bit size, bits per sample, which means the way we decided to store the data, which is where is it? Which is this part in 32, and this one is supposed to be the number of channels, so stereo, like left, right, kind of channels. But I see it is one here and two here. So, well, it works. So it works. Yeah, good one. Good catch. Now I can see it now. Yeah. I mean, I have no idea why it works, but if you guys can help me fix it, that would be amazing. Anyway, let's see what the create WAV header looks like. I'm actually used a lot of GPT here, so I won't be able to help you understand it too much. But basically, the WAV header need to have certain, let's see. It just need to follow like specific patterns. So the data itself is at the end. You need to tell it. Oh, 1 second, guys. Basically, the data here is at the end, bits per sample. This is the integer 32, byte rate, sample rate. I think this is the 1600 number of channels, audio formats. Let's see what. So this is basically just trying to align the audio, like create an header for what we've caught. I see there are some misalignment between int 32 and int 8. I will double check it later. It's great. Create the header and create the WAV file. Basically, create an array of the header size and the audio size, and then add the header and then add the audio data. And now we have a WAV file that is saved in memory, so we don't save it to the disk because we don't need to, and we can send it to OpenAI. So now we are going to make an OpenAI client audio transcription create, which basically the way to call Whisper model in OpenAI API, and then to file. I think this is not really needed, but I saw an example that used that, and I guess I copied that. And this is a prompt. I will let you know why this can be deleted actually, but I need to test if it actually helps. So the Whisper model, the Whisper AI model, can hallucinate quite a lot. When you send audio data that has no like speech in it. So if you just send sounds and voices and whatever, it's Whisper start to hallucinate and think it's like because it was trained apparently on a lot of YouTube videos, it will like from nowhere start like creating outputs of thank you for watching and see you in the next video and things like that. So I saw someone on Twitter just told me that if you add this prompt or like a prompt, it might actually help reduce these hallucinations. I actually didn't test it, but yes. And then we get the text. I convert it to lower just so I can check for the hallucinations that I mentioned. So if it is none, so this is where I hope the prompt will help. If it's none, or if it's nothing, or it is in null, or it includes both of those words, thanks and watch, then return that, just return and don't save anything. If it doesn't fall on this if statement, so hopefully it hasn't hallucinated, we move forward. Just know that this is like really rough. Like we need to work on this part quite a lot. Like it's still very, very bad. But if we have text, we are trying to embed it. So we again here using OpenAI client. We are using the A.2 to create embeddings. This like a really rough cleaning the text, like new lines and things like that to make it smaller and I've read somewhere that if you remove those things, like the embeddings works a bit better. But this is also a task that we need to do around the data processing that I mentioned on Discord. A lot to do on the data processing side. Yeah, that is actually true. The none check won't work. Yeah. But I check, the check here is on the transcript and not on transcript lowered. So the lowered I only checked for this one. So it actually will work. But that's a good thing to point out. Most of the code was written like at 3 a.m. So I do apologize for you guys trying to jump in and understand it. So once we got the embeddings, which is basically a vector, an array of numbers, we insert the whole thing into a new database entry in the table called records. We will go into that in a second. The raw text is the transcript that we got, and then embeddings, those two things. 1 second. Cool. I will go to the table in a moment, and you will see how it looks like. Yeah. And if for some reason it errored out, we just console it. And again, a lot of things around the error handling and things like that can be improved. And essentially, at the end, it just send an HTTP request back, an HTTP response with status 200, which is okay. Yeah, let's go to Supabase real quick. So this is just like a simple Supabase instance that I created just for the test. We have records, which is where all the data is being saved at. It has like an ID, created at, which are both automatically populated, and we have the raw text and the embedding. Now, I would imagine we will need more things here around, like create some kind of metadata or a bit more context to each entry in order to be able to retrieve things from here more efficiently in the next part. Cool. All right. Any questions on this function? Cool. All right. So if not, I will proceed to the next function. So this is the data where we process the data from the device, and then we have another function in Supabase that basically handle requests from the mobile app, from the mobile web interface. Okay. Remember this file, we will get to it again in a moment. Let's go to the mobile app, to the Next.js app, which is in under app source. Yeah. So this is the Next.js app. I would imagine it will change quite a lot in the next few days, but this is the basic, the fundamentals. You have this source folder where we have pages, styles, utils, and things like that. So the reason not to send to Wisp, this is actually a good shout. It might be worth sending. So someone asked why not sending the raw data directly from the device. And I think the reason I didn't do that is because I had so much trouble making the WAV header work that doing it with like the C++ code was like too much for me. But it might be a good thing to do instead of doing it in the in the in the in the Supabase function. In Supabase, you already have like the OpenAI API key, but I actually think it's a good shout. If we are using it, if we are using OpenAI, I think it's a good shout. Might need to look into that. If you want and try to make it work, I would love to see that. Cool. So the question: should the old raw data be cleared out of Supabase after you have the embeddings saved? So no, we actually need the raw data, the raw text, and I will show you why in a second. So the embeddings are being used only to find the text. So we actually need the text itself, but we use the embeddings to find the right text that we want. Yeah. The raw data, I mean the text itself. So this the transcript text. We do need to save it to the Supabase, to the database. Cool. Right. Where were we? In the app. So in the app, ignore all the folders and things like that. If you don't have background in React or Next.js, like it can be a bit too much. Essentially, everything that is in like relevant and that I actually did anything is the index.tsx and utils use Supabase config tsx. So these are the only two things that the main two things that I changed from the default Next.js app. So those two files. I try to make everything in one file to start with, so it will be less less complicated. But I'm sure we will split it to different files very quickly. Sorry, it's not the right file. This one. Cool. So let's start here. So this is the mobile app, or the web app has just one page, which is index.tsx, and it's this one. It checks if the user is logged in, and we have a user object. If so, show the chat. If we don't have one of those things, show the login component. The chat component, show the login component. So how those two things are being set? So we have I will dive into how the use Supabase works in a second, but it's actually not needed. Actually, I see it right now. So if logged in, meaning if we have a user object, set login to true. If you don't have one, set it to false, and then this changes accordingly. So how the login component looks like, we have 4 states, meaning we have 4 variables that we are holding. One is the Supabase URL, Supabase token, password, and email. And this what the form will change. So remember those 4 things. Cool. A lot of Tailwind CSS, header, Supabase URL. When you write things in this Supabase URL input form, it changes the state of the Supabase URL variable. Same for the tokens, same for the email, same for the password. And when you click login or Nexium, which I think it means something in Latin, and I use Google Translate for, might not mean anything as well. When you click this, it calls the email login function, and this is it, by the way, for the login component. The email login looks as follow. We are creating a Supabase client, and the reason we create a Supabase client here and not use the other way of creating a Supabase client like we have here, use Supabase client. The reason for that is because when you log in, you want to create, you don't necessarily have, from scratch. This use Supabase. It's a React hook that I created, and I will go into what it means in a second and how it looks like in a second. But basically what it means, it takes the Supabase URL and the Supabase token that you have saved and create a client and a user from it. So this will only work if you already have a URL, a token, and a user logged in. Otherwise, it won't work because you don't have the details. So the reason we don't use this at the top in the login page, the login page here in the email login, is because we don't have those things. We just got those things from the form input, and we want to create them on the fly. Why on the fly? Because it might be wrong. These credentials might actually not work. So we don't want to save those things into memory, into like the local storage if they don't work. So we create one manually. This is a function coming from Supabase SDK. And we're trying to log to, by the way, and this might fail. So if it fails, we say, we throw an error, like a toast error. If it didn't fail, we try to log in with the email and password as well. If there is an error, we throw the error. If not, if the login was successful, we set the Supabase config. So basically, we are saving the URL and the token for later, and we are router.push, meaning we are. It actually should be router.reload. We need to reload. I'm not sure if router ever reload, but I saw there is a bug where .push actually don't reload the screen and you don't get to the chat. You need to actually refresh it yourself. This is the line where the issue is. So this is the email. Cool. This use effect just like listening to the changes of the local storage of the URL and the token. If those two changed, then set. Basically, if you have those saved already and you logged out, it will show those two things anyway. Cool. So this is the login component. I hope it's somewhat clear. It's really hard to go over like a user interface. So this is like the 3 dots component, which I'm really proud of. It's this one. Hello. This 1, 2, 3. This one. This is just formatting the message. If we have like a new line there, we create like a new line HTML wise. It also can be improved dramatically. This is what this does. Journaling chat. This is what holds. This get like data. Data is all the messages. So from the assistant, from the user, from the assistant, from the user, and just shows it nicely. One green, one white, and adds animation. You see there is like a small animation here. So this is what this does. Cool. Yeah, let's go to the chat component. Cool. Any questions so far? Let's see if you have questions. Oh, I forgot my coffee. Okay, so the chat component. Again, remember this is probably going to change. It actually makes more sense to have it in separate pages, but I really wanted to start with just one file, like Kapati vibe, llama.c kind of vibe, where everything is just in one file. So this is why I did this. Bottom ref and text area ref. I don't think text area ref is being used. It is being used, but bottom ref is just like an HTML reference, so you can go to that area in the HTML if you want to. You know, when you click in like in a setup, you click and it goes to a location in the page. This is basically a reference. On message click, we will go into that in a second. Adjust number of rows. Yeah, basically adjust number of rows. When you write, it creates new rows in the text area. This is what this does. Use effect. When you get a message from a new message from the chat from the chat backend, it just goes to the bottom. So it scroll the screen to the bottom, so you won't have to scroll it yourself. New conversation, basically, we will go into that in a second. Fetches last conversation. Okay. I won't go into the GUI interface. I think it's a bit doesn't make too much sense. But basically, you have the bottom and the top. This code runs in the first time you run the program. It fetches the last conversation that you had. Conversations, it's just a raw like entry in the database. So you'll have conversations here, and when you open the app for the first time, it will either open the last one, and if you don't have one, it will create a new one. So fetch last conversation. It looks like that. Fetch only one. Order by the ascendance of equal false. If there is none, create a new one. Else, set the messages to that conversation and conversation ID to that ID. New conversation. This function is being called both when you don't have a conversation or when you click the plus button to create a new one. All it does, it creates a new entry in the conversation table with the context of, hey, how can I help you? Which is one item list. If there is an error, show the error and set the message to that. Cool, there is that. Cool. Now the important part, I think, is the on message click, which is the function that is being called when you click send message. So let's see how it looks. So it creates a new list with all the old messages and the new message, again in the right format that works with both OpenAI API and actually Ollama behind like a light LLM proxy, which is a nice setup. I will create a guide on how to do that with Ollama later. Set the number of lines to 1. It's only like a user interface. Set the messages to the new list and the entry data, which is the text in the area box, to nothing. It sets waiting for response to true, which this is the part where, based on that, you will see the 3 dots of waiting for a response. And then it invoke a Sababase function. it's it updates the database entry in the conversation table to the new messages. So it saves the new message, the full new messages list into the database, where the conversation ID equal to the current ID. Again, my code can be much more readable. Put in the time, and we will get there. But once it saves the conversation, it's invoke the chat function, which is another Supabase function, the second one. And after it finish after the function finishes, meaning we got the answer, we got the response, it sets the waiting for response to false, and then sets the messages to it basically adds the new message, the response, to the message list, which, because it's a state, automatically updates the user interface to include this. Cool. So this is how it works. We invoke the chat function and we send something called message history, and basically just the message list. And now we can go to this chat function and see how things goes there. Cool. Supabase function. So going back to Supabase, we have Supabase functions chat and index.typescript. And again, this is a Dino function. So it is a serverless function, and we serve it, the chat. And yeah, same here. If the request is I'm not sure why we do course here, not in the other function. Yeah, this is probably not needed. Here, because we are now the request is coming from the web app, which has a user login. So you logged in with your user, meaning like email and address, as part of the Supabase project. The request is being sent with an authorization header, meaning a JWT security token. So we take this token, the authentication token, and if you don't have one, then throw an error. We actually need to do that for the other function as well. I didn't do that because it was more like a writing function and not a reading function, so I was just worried about it straight away, but we definitely need to do that. So we take this token and we create a Supabase client with that token, meaning we will have the permissions of this user, the one who invoked the function. We actually get the user object itself. If there is no user, throw an error. And now we take the request.json. We look at the request as a JSON request, and we take the message history key data from the body. If we don't have message history, which again comes from here, throw an error. So just I will stop here for I saw that there is a few questions. Okay, so not sure what Dino is. So Dino, if you are familiar with Node.js or Dino is a JavaScript runtime environment. What it means? It means that you can run a JavaScript code somewhere. In this case, we're running this JavaScript code on Supabase Dino. So Supabase run a Dino server, and on the Dino server, we are running a JavaScript code. This JavaScript code and the way Dino works, okay, so we have this serve function, meaning it runs behind one second. It seems like the stream is over. 1 second. Okay. תודה. 1 second, guys. I think the okay, the stream for some reason stopped. 1 second. Yeah, sorry guys. I think I set it to a limit of 1 hour for some reason. So we will continue here, and it's all been recorded anyway. Just FYI. All right. Okay. I think most of the people are back. So again, I apologize. I set the stream to be 1 hour for some reason, and it stopped. Okay. So where were we? So we were in the chat function, where we were talking about Dino. So basically, Dino is a runtime environment to run JavaScript servers. These servers act as HTTP servers, so they are listening to HTTP requests and serve them. Meaning, what it means serve them, to just like do whatever. So they get the request, do something, and then return a response. And in a serverless way, that they don't need a server that is up and running all the time, and listening to requests. They are only being invoked once and run once they are being called, and this is what Dino provides you with. I hope that helped. So we get this we get the request, we get the authorization header, making sure we are able to connect to create a server-based client. We get the message history and throw an error if we don't have one. And then we create again an OpenAI client. An OpenAI client. And then what we do, we are taking the last message from the chat. So message history length -1 dot content. So the message itself, the text, and we embed that text. So we, for example, if the user asked, what is chocolate, we will take this what is chocolate text and embed it same way we embedded stuff in the other function. The reason we do that is because we then take the embedding, the vector, and trying to find the closest cosine record to that text. So we basically run, this is Supabase, I will show you what it is, but we're basically running a Postgres function. I will show you this function. This function is called match underscore records underscore embeddings underscore similarity. This is the name of the Postgres function, and we give it parameters. So the query embedding, the embedding of our query is the one we just created, and this is like give me top 10 results, and then the threshold, so how close the embeddings should be, it's 0.8. I'm not sure exactly how it's been calculated. We will see in a second. So this code takes the embedding of the question of the last message, and then trying to find the most relevant records from our database in order to answer the question in the most personalized way based on the user data. So let's see how this match records embedding similarity function looks like. You will be able to see it either in the schema.sql. Okay. So this is actually the function. The way we create the function. So create or replace function. This is the name of the function. This is the parameters it takes. Query embeddings, which is a vector. It also takes a match threshold, which is like double precision. I think it's a float. It means it's a float, and then match count, which is an integer, and it returns a table of the raw text and how similar this text is to the query embedding. And it's basically like an SQL query. So we are selecting. So from the table records, we are selecting records ID, records raw text, and the similarity. So cosine, I think this means cosine, and then basically the embeddings of the records, so what we have in the database, cosine with the embeddings of the query, 1 minus that. This is what we select as similarity, and then we basically returning the records that are matched by the match threshold, so closer than 0.8, and then we order by similarity. So basically the closest one is the top one is the closest, and then limit by match count, which is in our case 10. This is what this function does. This is basically the RAG, the retrieve augmented. This is what I meant by RAG. This is really bad, and this can really be much better. We probably should do embeddings, yes, but we probably need to do a knowledge graph as well, creating like understanding of the user itself, like their friends, their family members, their job in a non-embedding way. Not only embeddings, but a bit more robust way of retrieving the right data to answer the question. So once we get the most relevant records, the top one, let's go back to the function. So this is the function. We got the data into a variable named relevant records. And then if there is an error, throw an error. And then it basically, we create a new messages list with a system role. Okay. And then this is like the system prompt. You are a helpful assistant helping the user navigate through life. He or she is asking, this is really bad. This is a really bad system prompt. But the important part is that we put the most relevant records that we just fetched from database in the system role, and we tell it, you have access to some of the records to help you answer the question in a more personalized way. It's really simple RAG, but it works. It's really cool when it does work. And it can work many more times and in a better way if we will work on that part of the code. And then we create this messages list with all the message history. And then we just send a request to OpenAI ChatGPT-4. So with the messages, and then return the content to the OpenAI, to the Next.js app here. So this is the response that our page is getting. So once we get this data, again, we save the new data into the messages list on the client, and it will show up in the user interface. And that is it, I think, for most of the things of the code. Any questions on the code areas you want me to go and talk about again? Let me know. I'm here waiting. Okay, so it seems like the chat is disabled on Twitter. I'm trying to figure this out. Oh, that's so annoying. Okay, so it seems like the okay, I think I'm going to stop and start again. And I think what I'm going to do after is I'm going to set the whole system up from scratch. I'm going to create a new Cyberbase function, a new Cyberbase instance. I'm going to compile it. I'm going to compile it with the device and everything up and running. So I will start a new stream in a second. All right, let's see. All right, guys. So I'm going to set. All right, guys. As I said, I'm going to set everything up. So now I'm going to went over the code. Let's start. All right, guys. As I said, I'm going to set everything project. Up. So now I'm going to went over the code, get all the right details from it. Let's start. All right, guys. So next to everything project. So now I'm going to went over the code, get all the right details from it. Let's start. All right, guys. So next to everything project. So now I'm going to went over the code, get all the right details from it. Let's start. All right, guys. So next to everything project. So now I'm going to went over the code, get all the right details from it. Let's start. All right, guys. So next to everything project. So now I'm going to went over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right details. Project. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right. Let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right. Don't copy the unknown key. You can take it if you want, but let's start. All right, guys. So next to everything project. So now I'm going to over the code, get all the right. Don't copy the unknown key. You can take it if you want, but let's start. All right, guys. So next to everything project. So now I'm going to over the code. So as you can see, setting up the project, it might take like 2 seconds. Let's start. All right, guys. So next to everything. What I'm going to care about. Right, so as you can see, setting up the project, it might take like 2 seconds. Let's start. Right, so next what I'm going to care about. Right, so as you can see, setting up the project, it might take like 2 seconds. Let's start. Right, so next what I'm going to care about. No, it should only be this one working. Anyway, let's go back to Supabase. Anyway, we have Supabase up and running. We just created it. What we care about is the project URL and the API key, which I will copy in a second. Let's copy it right now. Okay. So let's say we just clone the repository. We just cloned the repository and we created a new Supabase account. Now we... Well, I forgot. Let's go through the GitHub repository. We clone the repository. We create a new Supabase account. We have the public key and project URL. Now let's go to authentication. Let's create a new user. And give it a password. Auto confirm. Cool. And now we added the user. Let's go to SQL editor. Let's go to the SQL editor and paste the entire schema. Let's run it. This is how it should look like when it's successful. It will create a new records table and a conversation table as follow. And yeah, now we can cd to Supabase folder locally. And I already have Supabase client, but you just need to reinstall Supabase client, or you can do it for Windows and Linux and things like that. You need to also install Docker. It's just install it and run it. It should run in the background. As you can see, I have it running in the background. And now Supabase login. It might not be the best to do it in front of everyone, but that's fine. Oopsie. Session ID. And then I'm going to link Supabase to my new project. So Supabase link -- project reference. I'm going to copy the project ID. I can find it. I think I can find it. Let's do a list. I can find it here. Cool. And then I'm going to do Supabase link to the new project, which is test live. You can leave the database password as blank. You don't really need it locally at the moment. And now we can deploy our functions. So let's copy that and just run the command. It's going to build it and upload it. Cool. It's all should be up there. Let's go to Supabase and make sure we can actually see the edge functions. Yeah. So we go to Supabase, edge functions, and we can see chat and process audio that were updated a few seconds ago, which is great. And now we can test it works. Let's go to Supabase. Let's get out of Supabase and let's go to the app. So cd app. We're going to npm install. I have everything installed already, so it should be fairly quick. And npm run dev, which will run it locally at localhost 3000. I can copy it and go to a new tab and see the project. It still connects to my old project, so I'm going to log out. And yeah, and I have the Supabase URL and Supabase token. It is a public token, so I'm not really too fussed about it. I'm going to copy the token of the new project. So project URL, going to copy here, and API key, going to copy it here, and then I'm going to log in with my, this is a test user, which login successful. This is the bug here. I need to just refresh the page and it should bring us to this page. Hey, how can I help you? Let's see. So test. So it's actually failed. I know why. Let's see. Cool. The reason it failed is because I did not provide an OpenAI API key. So if you go to the Supabase and then edge functions, and then in this case it is the chat, and go to the logs, we will see an error. The OpenAI API key is missing, so I will need to add it. Let's add it. So now you're not going to see me for a few seconds to see my screen. Okay, now back to the terminal. I've basically ran this command: Supabase secret sets OpenAI API key equal to this. Now let's see if it works. Test 2. Oh. Cool. Now that we have an API key, it works. All right, so we have Supabase up and running. We have our mobile app, web app connected to our Supabase. Now we just need to set up the device. So I connected the device using a USB-C to my laptop. And once it's connected, we should be able to see the orange light, and we will actually be able to run Python 3 check output and start seeing output from the serial, because it comes with software running on it already, so you probably will see something. In my case, I already have the Adeus software running on it, so it just says recording. So let's stop that and let's build it from scratch. So we will need to be in Adeus devices Coral AI. We will need to let's see. I mean, there are a few steps that I will skip. So you will need, after you clone it, you need to run submodule add and then submodule update init recursive. This will clone. It will take a few minutes, but it will clone your core micro dependencies into the folder. And then you will also need to run setup.sh to install the relevant stuff, which is like the make command, the cmake command, the compiler, and all of those things. One thing I will need to do is Supabase URL. I will need to export it. So let's do it. Let's go back to Supabase. Let's go back here. Project URL. Enter. So we did that. And then we will need to make cmake, which this command basically prepare the environment. It takes the cmake list file, and I'm not sure what exactly it do with it, but it makes sure that when you compile the make command, it has all the data that you need. So it will take a few seconds to run. If you've run it for the first time, it will take much longer than what it took for me, and it is completely okay. And then lastly, you will need to run the flash command here, which this will fail, right? Because I did not provide a Wi-Fi name and a Wi-Fi password, but I want to do it. I think the libusb will come with the setup.sh that you will run, but yesterday for some reason I was super tired and I deleted libusb. So yeah, cool. So let's run the flash again, and it will fail because I provided a Wi-Fi name and a Wi-Fi password that are completely incorrect. But I do want to show you that it fails. So it's going to copy the new file system into the device. All right. The device will stop running. Oh, 1 second. So the device will stop running. As you can see, it doesn't give you any output because it copies the new stuff into the microcontroller. It copies everything, and once it's been copied, you should see serial connection created. I'm not sure if this is the best thing to show you, but it's fine. Let's see. It's going to fail because I didn't give it the right data to the Wi-Fi, but let's see. Cool. Failed to connect to Wi-Fi name because it's not a real Wi-Fi name. Failed to connect to Wi-Fi. Good. That is what we wanted to see. Now I'm going to use my real Wi-Fi stuff. So I'm going to use a different screen and run the command. 1 second. I'm running the command on a separate screen. And you can see that because, oh, 1 second. Now it I mean, you can see the password, but that's fine. I will give you that. And you can see that it failed because I copied a new file system into the device. So we need to run check output again, and it's connected to the serial. And you can see my IP, and it starts recording and recording and recording and recording and recording a lot of things. And it might take up to 1 minute to finish. In the meantime, I will keep recording myself speaking, talking. This is a something. Let's see. Let's see. It's still running. Let's go to the server base in the meantime. So as you can see, the table is still empty. Yeah, it's still empty because it's still recording the first recording. Let's see. Now it's sending the data, and it failed. What a lovely stuff. You know what? I'm going to, you know what? Let's wait 1 minute again. I was about to say, let's set it to record every 10 seconds and not 1 minute, which you can change here. You can change here to 10 seconds, and this should do, but I will compile it again later. Let's see. It's still recording this second time. Let's see. Let's hope it won't fail this time. Recording. And I will always love you. And it's sending the data again, and it fails again. Oh man, why it fails? The kernel is not the best. Why it fails? Well, let's give it one more time. You know what? Let's No, let's wait one minute again, and afterwards, feel free to ask questions, because after that I will finish the stream. The kernel can work a bit more reliable. So the reason it fails, by the way, is that for the first few times, for some reason, it takes the DNS lookup a while. So the issue here is it cannot find the IP of. It has just issues with the DNS, but once it finds the IP, okay, so now it found the IP, and from this moment forward, it will stop failing. So just the first time it runs, it needs to find the IP, and that is it. So it sent the data, and it should invoke the cloud function, which it did. And now we should see the text. Here we go. Yeah, it works. Amazing. Awesome. So with that being said, now you can ask some questions. Okay, now feel free to ask some questions, guys. Yeah, let's see. Let's make myself bigger. Woo. So which part handles the transcription? So let's go back to the code. So the part that handles the transcription is when you go to your Supabase folder, and then you have the process audio function. You get the raw audio from the device here, and then you convert it to a WAV file, and then send the WAV file to OpenAI API Whisper model, and this handle the transcript. And I have a somewhat version working with Llama and local Whisper, but I will go over it another time. If you have more questions, guys, let me know. And in the meantime, let's keep seeing the. Here we go. It keeps listening to me. Cool. So it seems like there are no more questions as far as I can tell, which is lovely. Um. So, Itrath is writing. So let's wait for his question, and then we will finish off. So what we did today, we literally went over the entire code base in less than 2 hours, and it was mainly me like talking too much. So you can actually understand the code, I think, within an hour. You can fast for like make it like twice as fast if you want. I will upload the recording to Twitter and to YouTube. And after we went over the entire code, we also just set the entire thing from scratch as well. We created a new Supabase project, run the local app, and rebuilt the on-device software, and so it's also failing and also succeeding. We saw all the bugs and all the issues and all the areas that we need to work on, which is, I think, is good to see it live. And do let me know if you have any more questions afterwards. If you want to join the Discord channel, either DM me on Twitter, and if you cannot DM, just comment on one of the posts, and I will try to reach out to you. And yeah, help us build this thing. Let's make it a real thing and not just a nice project. Cool. Bye, guys.